Hello and welcome students, welcome to another year, to a new semester here at the HTBLA Leonding. For those of you who are not in my class but who are watching this video just online, my name is Rainer Stropek and this is a fundamental course for C#. Now, last year we worked on C# basics. You learned about variables, constants, loops, conditions, methods, and many other things that are super useful foundations for doing some coding work. This year, we are going to continue our journey towards becoming professional C# developers. And we are going to kick off the year by talking about how to structure more elaborate, more complex software solutions in C#. We are going to talk about solutions and projects. Let me give you a quick introduction. I will draw here a little bit. Imagine that you are building a larger application. Let's call this larger application the Math Tutor application. And inside of this Math Tutor application, you have two parts. On the one hand side, you have the logic of your app. Let's call it mathtutor.logic. This is frequently used when naming things. You are using the name of the company or project, and you use a dot, and then you define the detail that you are currently specifying. In this case, it's just the logic of the Math Tutor. And then for the second thing here, we create a second, let's call it project, which we call mathtutor.app. This will be the app that the user uses in order to interact with the Math Tutor logic. Now, why do we do that? We do that because as programmers, as software engineers, it's important for us to reuse logic. In this case, we are going to add or implement some very simple mathematical operators, and we maybe want to reuse these operators later on. So therefore, we are going to put them into a so-called class library, into a dedicated project. We are able to share this project with other programs or with other people. So we don't want to build one large program CS file, but we want to structure our applications into multiple parts. And in our case, we are going to implement the class library with the logic of our application, and then the app with the user interface of our application. With that, we can easily give the logic to somebody else or reuse the logic in a subsequent project. Let's try that. Let's try exactly that. Please create a new folder for today's exercise. I recommend using the folder name Math Tutor because then you can easily follow along exactly. I already did that. I have a completely empty folder. As you can see here, no files here. I am using Windows with the subsystem for Linux, so I'm using a Linux shell here. If you use a Windows shell, that's absolutely okay. What you need in order to continue with this course is you need to install .NET. We did that last year. If you are not familiar how to install it, revisit the videos that I created last year for you. For those of you who are watching this course online, just check my YouTube channel. I'm pretty sure you will find the videos. Now we have a completely empty folder and we are going to start Visual Studio Code with this completely empty folder. So in contrast to last year, we did not create the console app by running .NET New Console. We did that last year over and over again, but no longer this year. This year, we start Visual Studio Code with a completely empty folder, as you can see it here. Now, why is that good? Because I will now introduce you to a brand new extension that we are going to use this year very heavily. You can go to the extensions here and maybe type C# up here to look for all the extensions that are available here for C#. Now, last year, we used exactly that extension. And this year, we are also going to use that extension, but we are going to add the second one, the C# DevKit. I want you to install both extensions in your Visual Studio Code. Make sure both extensions are available. The upper one is pretty new. It hasn't it hasn't existed last year, I think, at least at the beginning of last year. It is pretty new. It's only available for some months now. Pause the video if necessary and make sure that you install the C DevKit. Welcome back. I hope you paused the video and you successfully installed the C DevKit. So we can go back here to our Explorer. The question is, how can we create a new project, or especially a collection of projects that we call a solution? Remember that name, solution. We are building a solution, and the solution consists of multiple projects. MathTutor.logic is one project. MathTutor.app will be the other project. So let's create a new .NET application inside Visual Studio Code, and we do that by pressing the F1 key, and then simply look for new, something like this. And if your computer works just like mine, you will see one option here which says .NET new project, and this is exactly what we want. Let me repeat that. Press F1, type new, and then select .NET new project. Now you get asked a bunch of questions. The first question that you get asked is, hey, Rainer, which kind of project would you like to do? And you see a bunch of very fancy stuff, ASP.NET Core, Blazor, and MS Test, and a lot of other things. But for this year, we are focusing on these two things, the class library project and the console app project. Now, what are these two things? The class library is just a collection of functions and data structures. It is not executable, it's just a collection of functionality, perfectly suited to encapsulate something that you would like to share with other apps that you build or with other people that you work together with. The console app, you know it already from last semester. So let's get started with the new stuff, with the new kid on the block, and that is the class library. So again, press F5, choose new, and somewhere we should see, here, the .NET new project. And then let's go for the class library. The last thing that we have to enter is the name of the class library. And I already told you, call it MathTutor.logic. That should be the name of the class library. Press enter. And yes, the default directory is fine. And you see the new plugin created two things for us. Here on the left-hand side, you can see it. It created a solution file for us called SLN. The solution file contains information about which projects are part of the solution. It's the overall structure that sits on top of all our projects. And the second thing is the project itself. That is a subfolder. As you can see, this is a subfolder here. And inside of the subfolder, we have a C# file, class1.cs, and a csproj file. Last year, we ignored the csproj file. This year, we will take a look. We can ignore the bin and ignore the object folder. They are useful, and you will learn about them later on. But for now, only the C# file and the csproj file are important. Note that we have a class file here, not a program CS. That's important, and I will tell you why in a second. Now we have a solution with a single project, but that's boring. We want to add a second project so that we can really see what solutions are all about. So repeat what we did before. Press F1, choose .NET New Project. This time we are going to use the console app. We know console apps. Let's call it MathTutor.app. Here we have it. Choose the default directory, that's fine. And now you see the full beauty of our solution. Oh, sorry, I didn't want to open this file. We see the solution, that is the entire MathTutors thing. Then we have one class library in there, that would be the logic part here. And then we have a second thing here, which was the app, as you can see here. So now you see the same structure that I've drawn before on the screen, a solution with two projects. Down here, you see a new window part here, which is called Solution Explorer. Please look for it. It's important. And please open it. You can close these things and open these things easily. And this Solution Explorer will come in very handy when we have to do some configuration work inside of Visual Studio Code. Now, what kind of configuration work could we do? The first very important thing that we have to do in the Solution Explorer is to tell C# that the app, the MathTutor app, which is the user interface, is referencing the logic because the app uses the logic. Referencing means that the app is consuming, is using the algorithms and data structures in another library. So what we need to do is we need to right-click here on the app and add a project reference. Do you see the menu item here? Add project reference. This is exactly what I mean. We tell C#, let me repeat that. We tell C# that the MathTutor app is referencing the MathTutor logic because we would like to consume the logic from within the app. So let's do that. Add project reference. Well, we only have one additional project, so it's very easy to choose. We only have one option, so of course, we choose this option, and now we are fine. Now, the app here knows that it can use the logic. Another folder appears, this .mono folder here, ignore it. It's not relevant for us. This is a folder that the C# extension maintains for itself. It's not relevant for us. Now, what happened internally when we create this reference? Let's open up this app folder, and for the first time in your C# career, you take a conscious look at the CS_proj file that we see here. Now, inside of the CS_proj file, you see a data format which is called XML. Maybe you have heard about XML in other courses in this school. If not, just trust me, it's XML. Inside of this XML, we have a bunch of settings. In my case, I'm using a so-called preview version of .NET 8. .NET 8 is not there yet. It's only a preview, and it's perfectly fine for you to use .NET 7. You do not need to install .NET 8 now. It will become ready to use for production purposes in November this year, I think. I'm using the preview because I want to learn about new things early, but it's not necessary for you in this course. .NET 7 is perfectly fine. However, the important stuff is going on here. Here you see that the app, we are still here in the app CS project file here, is referencing the logic. See it here? So here we see as a setting in the CS_proj file that the app references the logic. And this is exactly what we want to have. So please, let's revisit the structure that we have created so far. We have built a solution. This is the solution. Inside of the solution, we have built a class library with the logic. And we have built the app, which will contain the user interface. The app uses the logic. Therefore, we have created a project reference. This is the important thing that you have to remember. Nice. Now that we have created our overall structure of the solution that we are building, we can start writing code. Let's focus on the logic part first. Please open the class1.cs. Oh my goodness, we have a lot of new things going on here. First, the first line says namespace. We have never talked about namespaces before, something new. And then we see a class. Some of you have already learned about classes. Classes will be a very important part of our course in the next few weeks. We have to talk about both of them. But let me emphasize one thing. We are not diving deep into classes yet. First, we need to understand how to structure a solution into multiple projects. Then we can build on top of this knowledge and explore classes in more details. But first, let's talk about this namespace thingy here. What is a namespace? Let me draw again. So far, you know we have a solution, we have a project, and we have a second project. I'm boring you now because I told you exactly that. But to be honest, in a more complicated, let me note that one here. This is the class lib. Okay? In a more complicated project, you have a lot of classes and functions and data structures and records and all this stuff. You have a lot of stuff going on inside of this class library. Now imagine that this project is so complicated that multiple people work on a single project. Maybe we have Adam working on this math tutorial logic, and we have Eve also working on this math tutorial logic. Now, both of them, they decide that they need a class, maybe something like basic operators. They say, I want to build a class which is called basic operators. But unfortunately, they use the same name, the same class name. Now C# is confused. Whenever you write basic operators, what do you mean? Do you mean the class basic operators that Eve has created, or do you mean the basic operators class that Adam has created? This is what namespaces are all about. Namespaces are a possibility to structure a more complicated class library deeper. So if you have a large project with lots of classes and lots of people working on it, you will have dozens, maybe hundreds of these C# files inside of this project here. And well, it could happen that the same class name is used multiple times and then you have a problem. And for that purposes, you can structure your projects into folders and namespaces. To be honest, in our exercise here, we are not going to create a very complicated class library, but still namespaces must be present here. In our case, in our simple case, the namespace here is identical to the name of the project, Math Tutorial Logic, and that is fine for now. Of course, we could change it. We could say this is the basic math part. And we could create another file which is called advanced math in the namespace. So here we can add a more detailed structure of our project to make sure that even if we use same class names, C# doesn't get confused because the class name is unique inside of its namespace. If we have multiple namespaces, we can reuse the same class names. For now, it's perfectly fine to have a single namespace here because our class library will be rather simple. Now, the next thing that we have here is our class. In C#, there is a rule. Everything must be in a class. If we create a function, it must be in a class. If you allocate some memory, you must have it inside of a class. Everything is happening inside of a class. Well, there are some exceptions to this rule, but for now, let's keep it simple. Whatever you build as a function must be inside of a class. Now, you might say, well, Mr. Strobeck, we have the program CS. And here, last year, we have learned that we can easily define something like this here, a method, do something that can, I don't know, print something on the screen. And you see, this method is not really inside of a class. Haha, I will tell you a secret now. It is in a class. In reality, program CS is just simulating simplicity. In reality, C# will add a class for you. It will wrap the code that you write in program CS inside of a class. It will even wrap it into a method which has the name main. Main method. You simply don't see it. Microsoft introduced this functionality to simplify the starting with C#, but in reality, C# demands classes for everything. Exceptions make the rule. In a few weeks, I will tell you more. There are exceptions to this rule, but currently just accept that everything must be in a class, okay? And in Program CS is not something special. C# will just generate the class for you. You don't see it, okay? Let's go back to our class1.cs file. Now, we can think about how we want to name our class. For that, we need to understand what a class is. Well, not really, because there are two different kinds of classes. There are regular classes, which you will learn about maybe next week, maybe in 2 weeks. And then we have so-called static classes. And this is what I want you to change now. Please make this class a static class. What is a static class? It's a lightweight class. It's a class which is essentially only a collection of functions. Yeah, it can contain nothing than functions. Well, again, it's technically not true. There are a lot of things you can put into a static class, but for now, keep it simple. For now, a static class is just a collection of functions. In a certain way, it's just another namespace, if you want to put it like that. It's just a namespace. It's just a container where we can put some functions in. Okay, that's a static class. It's just something that is wrapped around a certain collection of functions. And you typically create a static class to group functions together which are logically connected. A lot of theory. I think we have to write some code, and I'm pretty sure that you will understand what I mean in a second. Let's first go and rename our class and rename our C# file, because class1 is not a beautiful name. Let's call it basic operations, okay? I renamed the file to basic operations, and I also will rename the class1 to basic operations, okay? So this is now a container for basic math operations. We can group all the methods that represent basic math operations in this static class. Let's do exactly that. I invite you to follow along. We are going to create, GitHub Copilot, my friendly AI assistant, already suggests something, but to be honest, I would like to disable GitHub Copilot for now, because GitHub Copilot is spoiling everything. So yeah, I want to type the code myself. Let's create the first basic operation. Let's say public int add int x int y, and then we say return x plus y. I think you get the idea. Now we get an error that we cannot create the function here, so just trust me for the moment. In front of the function, we also need the keyword static. I am aware that you probably are not fully aware of what this static means, but you have to just trust me for the moment. In a few weeks, you will have all the knowledge and you will really understand what this static means. For now, just trust me, it's necessary here. Also, trust me that it's a good idea to say public here. Public essentially means that the class library is making this function and this class public. So everybody who wants can use this function. So it makes it public so that the app can use this stuff. And yes, if you think what could be the opposite of public, of course it would be private. But a private method is kept private, as the name suggests. So the app cannot access the method. There are more so-called access modifiers, and I will tell you more in the upcoming weeks. For now, we just define everything public and we are good. So this is a very fundamental basic operation. Please stop the video here and try to catch up. Good. Next basic operation. Let's add the second basic operation, and that will be the subtract operation. Int x, int y, and you can guess it, return x minus y. And last but not least, we do a multiplication, okay? Public static int multiply int x int y and return x multiplied by y. So please follow along, type in this code if necessary, stop the video so that you have enough time for typing in this code. Good, so now you see that the class is really a nice functionality to logically group our functions together. We can add more classes if we have functions which are not really on the same topic than add, subtract, and multiply. If we do something with files, we could create a class which is called file operations, and we can add a method which is called read file or something like this. So classes are just a possibility to group functions which are logically connected. And in our case, basic operations has add, subtract, and multiply. Everything else except this public and static is exactly as we have learned it in the last year. So I assume that you can remember what we did last year in that regards. Nice! Now we have created a class library with a single static class and 3 functions. Let's try to use these 3 functions in our app. So I go here to the app and open the program.cs. But wait, don't click on it yet. Press the Alt key on your keyboard and then click on the program.cs. If you do that, you will get on the left-hand side our basic operations class, and on the right-hand side you will see the program.cs. That's very handy because with this we can really see both parts, both projects at the same time. So now let's first consume one of these basic operations. Can you remember? The app project references, has a project reference to the logic. This is the reason why we can use wrong arrow direction, why we can use these operations from within the program.cs. Let me show you what that means. Let's get rid of what we have here in program.cs, and the first thing that we need to do is we need to make this class available by telling C#, that's also new for you, that we want to use this namespace. So therefore we say use using mathtutor.logic. See? We say I am using mathtutor.logic. And with that, we can, for instance, say var x equals, use a different variable name, a equals 10, and var b equals 20. We can say var result equals 2, and guess what? Basic operations is now available, and with a dot, we can get all the different methods inside of basic operation, and we can choose the add method and pass a and b as parameters. And finally, we say console.writeLine the result. The important thing that we just did is we put these functions in a separate project, in a separate namespace, in a separate class. And then we have a second project where we consume this method, as you can see it here. And we achieve that by adding a using statement and by specifying the class name in front of the method. So I think you can now imagine how you could structure a much larger applications. More classes, more namespaces, more projects. I've worked on code bases with hundreds of projects, with tens of thousands of files, and with tens of thousands of classes. In large business contexts, that's absolutely possible. In our small, tiny, teeny little learning environment, we will probably only have solutions with 1, 2, or 3 projects, and each project contains, I don't know, 1 to 20 classes, something like this. That's fine for your second class. For now, everything is good with only these 2 things here. Let's give it a try. How can we run it? Well, it's very simple. We simply open the terminal. Can you remember the terminal? We have it here. And then we still say .NET run. Does it work? No, it doesn't work. You see, because .NET run is now running on the, let me show it to you, solution level. And .NET tells us that it doesn't know which project to run. Unfortunately, it's not smart enough to recognize that there is only one project that we can run. The second one is a class library. It cannot be executed. That's not possible. It's not smart enough. So what we need to do is one of two things, one of three things to be more exact. First thing, we can use the -- project setting. So what we can do is we can say .NET run -- project mathtutor.app. Run it, and hopefully we will see a result that is 30, because 10 plus 20 is 30. Woohoo! It worked. So specifying the project to run like this is possible. The second possibility is to change directory into the mathtutor app folder. Now I'm inside the folder of the app, and now I can use a .NET run without any parameters. It will simply work. Okay? And what is the third option that we have? The third option is available here in the Solution Explorer. We can right-click on the mathtutor app, and here we have multiple options, as you can see it here. We can build it. Oh, I thought it would be possible to execute it too. Let's see, maybe I remembered something wrong. No, there is no run option. I'm very sorry. We cannot run this thing directly. So you have to either change directory in the subdirectory or choose the project with -- project. Please try that. If necessary, stop the video here. Please try to run this program CS code. Try one of the two options, or even better, try both options, so you are really familiar with what's going on here. Have you been successful? Did it work? I hope it worked. If not, just go back in the video, take a close look what I did differently, and try to follow along. Okay, this was our first lesson. You learned about a new plugin, a new extension of Visual Studio Code. You learned about class libraries. You learned about namespaces. You learned about static classes, and you learned about project references. Now it's time to exercise. I have created a homework for you. Let me show you the homework on which you can work. Okay, I created a GitHub repository for you, which is called rstropek, like my name, and then the years 2023-24. That will be our school year, and second is your class. So this is the second class of your career here in the HTL, and the year here. And here I created a subfolder homeworks, and here you have your first homework. It's the geometry calculator. For those of you who are here in school, you can start working on the geometry calculator here in school. I will obviously help you overcome any problems, and you have to finish the geometry calculator at home. For those of you watching at home, not being in my class, you can do the geometry calculator on your own. Now, what is the geometry calculator all about? It's very similar to our math tutor, but the business logic is a little bit more complicated. Not very complicated, but a little bit more complicated. You have to practice exactly what I've shown you before. You have to create an empty folder. Then inside of this folder, you have to create a class library. If you can't remember how I did it, rewind the video, rewatch it. You have to create a console application. If you can't remember how I did it, rewind the video and rewatch it. Inside of the class library, we need, this time, 3 static classes. See? Not a single one, but 3 of them. You can decide on your own whether you put all the classes in a single file or whether you put every class in a separate file. That's up to you. You are now already on your way to becoming professional developers, so you have to make some choices. Both things are possible. Single file, 3 classes, 3 files, every class in a separate file. Now, what is the whole business logic purpose of this example? The business logic purpose of this example is that we provide some helper methods to work with geometry, with geometrical figures. For instance, we have a circle. Now this circle has a certain radius, so radius r. This is the given radius r, okay? And the question that we need to answer is if, oh sorry, I typed something wrong, I'm very sorry. So this is what I wanted to type. The question is, we have a given radius r. I wanted to do oh, it's already late in the evening. I'm kind of lost. I think I did too much work today. So here, now we have the radius here. Now we have a circle with a given radius, and the question is, what radius do I need to double the area of the circle? So we are looking for this radius down here. Let's call it r dash here, okay? That is what we are looking for. I have a given radius and therefore a given area of a circle. The question is, what does the radius need to be in order to double the area of the circle? You see, for that, you have to implement 2 methods. One is called calculate area, which is capable of calculating the area of a circle, calculating the area of a rectangle, and calculating the area of a triangle. If you can't remember the formula for calculating the area of a rectangle, circle, or triangle, please use Google or your favorite search engine or your favorite AI assistant, or simply ask a teacher like me. The second method is the interesting one. The second one here is thought for creating or for scaling the area. So for instance, let's talk about the rectangle. The rectangle has an original width and height. And now we want to add a certain factor or multiply a certain factor on top of the area to get a larger rectangle. So for instance, we have, we have this rectangle. It has a certain width and it has a certain height, okay? And the question is, if I apply a factor 2, that would be the double of the area, how wide must the rectangle be and how high must the rectangle be in order to end up with the double area? That is the question you have to answer inside of this function. And in analogy to that, you have to answer the same question for the circle, given the radius, and the same question for the triangle, given the base and the height of the triangle. Just to make sure that everybody knows how a triangle looks like, let's have something like this. Okay, this is a triangle. Then this here would be the base, and this here would be the height of the triangle, and can calculate the size, the area of a triangle with the base and the height. Good? Once you created this class library, you can create a console app. Now inside the console app, you have to ask the user which type of geometric figure she wants to use, rectangle, circle, or triangle. Depending on the geometric figure, you have to ask the user for the width and the height when it comes to a rectangle, the radius when it comes to a circle, and the base and the height when it comes to a triangle. Then you have to calculate the area of the geometric figure and the area of the scaled figure. Yeah? we want to ask the user, what factor do you want to have? If the user enters a 2, the user wants to have double the area. If the user enters 3, the user wants to have 3 times the area. And last but not least, we print the new parameters after scaling the geometric figure. In order to get a rectangle with this width and this height, you need to change width and height as follows. This is the kind of print that you should do here. Now the question is, how do you calculate the new values? I don't want to bore you with math. If you would like to really understand how I got to these equations, ask your math teacher. But I wanted to make your life easier, so I gave you the formulas, okay? The thing, how you calculate the new width and height for a rectangle, the new radius for the circle, and the new base and height for the triangle is always the same. You take the old value, in this case the old width, and you multiply it with the square root of the factor. So let me show you an example. Very simple. Here, imagine that we have a circle with radius equals 2. Now we have a factor of 4. So we want to end up with a circle that has 4 times the area of the original circle. Then the new radius, r dash here, is the square root of the factor 4 multiplied by the old radius, and that is 2. This is what this formula means, okay? So this is how you calculate the new values, and this is always the same for all geometric figures. Okay, give it a try. If you are lost at home and you cannot ask me, see what I did? I gave you a solution here. Don't take a look too early. Try it. Try it as much as possible. If you are in my class, ask me. Ask for help to overcome problems. If you don't understand the exercise, ask me. I will describe it to you, if necessary, over and over and over again. But it might happen that you sit alone at home and you are somewhat confused. Then you can take a look at the solution. I will not open it up here because then it would be a spoiler alert, but it is here for you to take a look if you are lost and you cannot find your way through this exercise. Nice. That's it. So get started, build this app, build an awesome geometry calculator. I'm looking forward to your questions and I'm looking forward to your solutions. See you next week. Bye.